All right, we're going to look at a few questions from exercise 13A. This is probability. It's to do with discrete variables, which the variables blocks of counting numbers. There's no decimal places in this variables. It's just discrete. The other types of variables is continuous, where you can have decimals, like measuring time, milliliters. Question 1, an experiment consists of rolling a dice and tossing a coin. So there's a dice and there's a coin, all right? Heads or tails, all right? So just put heads on this side, tails on the other side. Use a tree diagram to list the sample space. Well, a tree diagram starts with the first roll. And what are the possibilities for the first roll? We're going to roll the dice first. So it could be a 1, a 2, a 3, a 4, a 5, or a 6. A 1, a 2, a 3, a 4, a 5, or a 6. The second event is flipping a coin. It could be a head or a tail. So depending on from each of these branches, it could be a head or a tail, head or a tail, head, tail, head, tail, head, tail. And there it is. The list is, it could be a 1 and a head, a 1 and a tail, a 2 and a head, a 2 and a tail, a 3 and a head, a 3 and a tail. So we get that by following the pathways. It could be a 1 and a head. That's one possible outcome for the first roll, and then flip the coin. It could be a 1 and a head. The second event is different than the first event. It could be a 1 and a head. So a 1, sorry, and a tail. And there are altogether, let's finish it. Down here, we're at 4. We're up to 4 and a head, 4 and a tail, 5 and a head, 5 and a tail, 6 and a head, 6 and a tail. And this is the sample space, okay? So we could say that the sample space is the list of 1H, 1 tail, 2 head, 2 tail, 3 head, 3 tail, 4 head, 4 tail, 5 head, 5 tail, 6 head, 6 tail. And that is the sample space. Bracket around that. Question 4, a blank 6-sided die is marked with the numbers with 1 on 2 sides. So we've got a 1 and a 1 on 2 sides. We've got 2 on one side, 3 on the other 3 sides. Okay, so we've got the numbers are on this dice are 1, 1, 2, 3, 3, 3. Okay, so that's the numbers on that dice. That's the sample space. If we just roll the dice once, it could be a 1, 2, or 3, really, which is, it's a 1, 2, or 3. They're the only possible numbers on that dice. Find the probability that when the dice is rolled, a 2, a 3 is shown. Well, the formula for probability of an event is the number of times that event can happen divided by the total number of possibilities. And you can see that there are 6 total possibilities because there's 6 sides on a dice. And how many are 3 is 3 out of 6. So the answer is a half. So the probability that a 3 shows is equal to a half. All right. Part B. A 2 or a 3? Well, probability of a 2 or a 3 is the probability of a 2 plus the probability of a 3 minus the probability of a 2-3 happening, which it's not possible to get a 2-3 happening. So it's just the probability of a 2 is 1 out of 6. The probability of a 3 is 3 out of 6. So the answer is 4 over 6, which equals 2/3. At a particular university, the probability that an art student studies a language is 0.3. So the probability that they study language is 0.3. Probably they study literature. Oh, that's not going to work. LA is language. The probability they study literature is 0.6. The probability that they study both literature and language and literature is 0.25. Now, if you remember that rule I wrote up here, we want the probability that they study either language or literature. Okay, so the probability that they study language or literature equals, and that's the probability that they study language plus the probability they study literature minus the probability that they study both language and literature. So we've got these probabilities. We've got 0.3 plus 0.6 minus the probability they study both minus 0.25. So that's 0.9 minus 0.25 is 0.65 is the final answer. Okay, thanks for watching.